Hi students, how are you? I think we're all doing well. Very nice. As you know, today I will continue the next part of the matter around us lesson. Okay? Are you ready to listen? Okay, very good. Now we learn the next part is effect of temperature on the states of matter. Okay. Then at the end of this lesson, you will know what is the effect of temperature on the states of matter, and the on heating the particles they gain energy, and you can know so many points like this. Okay, particles having more energy when the temperature is more, and temperature at which the solid completely converts into liquid is called melting point. About the boiling points, okay, that is about what is the boiling point. Temperature at which the liquid converts completely into a gas is called boiling point. Okay, they are all temperatures. Melting point and boiling points are temperature. And now the latent heat, okay, is a new concept, that is latent heat of vaporization and latent heat of fusion. So what is this latent heat? They're all you can know in this lesson, okay, or in this part of this lesson. Understand? Yes, children. What are the three states of matter? You know it is solids, liquids and gases. Okay. So for the first one, the effect of temperature on the states of matter from solid to liquid. When you heat the solid, it becomes liquid, isn't it? Suppose when if you take the water, water exists in three forms. One, ice, and also the water and gas or water vapor. So first of all, we will see when you heat the ice or a solid ice, it converts to liquid water, isn't it? So for that, we will take some ice cubes. Okay, what we will do for this activity? We require a beaker which is filled with ice cubes. Take that beaker which is filled with ice cubes and measure the temperature with the help of a thermometer. Observe the reading. Okay, then take this beaker with ice cubes and put it on a tripod stand and start heating. Okay, then ice slowly melts into water, isn't it? Okay, so what you will observe, okay, when you slowly the temperature rises, so that means ice slowly it gains the temperature and gains the heat energy. So energy is increasing, heat energy is increasing. Okay, slowly the temperature rises for every minute. Okay, till all the ice melts into water. Okay, all the ice melts into water. At that time, you observe that there is a no change or rise in the water when ice starts melting, and completely if it becomes water, there is no change in the temperature, but initially ice gains the energy, so temperature rises. Okay, so what we can say then, what are the observations? Temperature of the mixed solid ice and liquid water does not change when when the ice starts melting slowly into water. The temperature does not change, remember. Okay, if it is 0 degrees ice, if the less than temperature, if it is the ice temperature is -10, slowly it comes to 0, and from 0 ice and it becomes 0 degrees water. 0 degrees ice to 0 degrees water, there is no change in the temperature. Okay, again when you heat it continuously, then that 0 degrees water slowly increases its temperature. Okay, so the temperature starts changing again, rising again, only when all the ice melts into. Okay, then what we can conclude? We can conclude that temperature at which the solid melts to liquid is called melting point. So what is the melting point? Temperature when the ice starts melting, it starts melting to water. Then we say that point is called, the temperature is called the melting point. The process is called the melting. What is it? Process is called melting or fusion. When you take water, it is ice melts into water. But when you take the other liquids or other solids, convert, see, all the three states of matter can be converted. If you take iron, iron also becomes liquid iron. Iron can also be made it into the vaporized. Okay, that means all the states of matter can be exist in three phases. Okay, so here the changing into solids to liquid, the process is called the fusion. So what is the conclusion? The fusion. Okay, fusion means changing the solid phase into liquid. So here, what is the melting point? Temperature at which the solid melts to liquid. It's called melting point. In the melting process, the temperature remains the same. There is no change. But before melting, the change in the temperature is exist. After melting also, change in the temperature exists. But at the time of melting, there is no change in the temperature. Understand? Okay, now the ice melts into completely into water at 0 degrees. Now again, if you change or if you heat it continuously, slowly, the liquid can also become gas. Initially, the solid melts or fusion taking place and change it into liquid. Now the liquid can also be converted into gas. How? Take the same water into the beaker and put it on the burner, okay, or the Bunsen burner, okay, or spirit lamp, and observe the temperature for every 2 minutes until it reaches 100 degrees centigrade. So the 0 degrees centigrade water, slowly the temperature rises. After 8 minutes or 10 minutes, it reaches to 100 degrees centigrade. Note down your observations. Okay, happen the temperature increases and slowly the liquid becomes gas. That means water becomes water vapor. So water starts boiling at what temperature? At 100 degrees temperature. If you still heat above 100, for some time the temperature remains constant, that it will not change. Okay, why? Because all the liquid will convert into gas or water vapor. At that time the temperature remains constant. Okay, the particles in the water vapor having more energy. Why? Because you are supplying the heat energy, but the temperature is not changing. What will happen to that heat energy which you are supplying? Will be utilized by the water to convert from water into water vapor. The molecules will get free and escape from the surface. Okay, there if you observe the temperature remains constant. So what we can conclude from that? We can conclude that at certain temperature, the particles have enough energy to become free from force of attraction and start changing into gas. So that process we call the, normally we call them as the evaporation, and the temperature we call them as the boiling point. The temperature at which liquid starts boiling at the atmospheric pressure is known as boiling point. So here, when your mother kept this vessel on the LPG stove, okay, what is the pressure outside? It is equal to the atmospheric pressure. Okay, at that pressure, the water molecules try to escape out by gaining the heat energy from the source, and they try to, the molecules will escape out and converted into the water vapor. So that temperature at which the liquid starts boiling, okay, at an atmospheric pressure is known as boiling point. Children, one more important concept we have to learn, that is latent heat. See, what is this latent heat? It is also heat energy. Okay, and what is this extra heat? That is, what is this latent heat? See, if you observe, when you are heating at one temperature or 0 degree centigrade, ice slowly melts into water. What when you are supplying the heat from the source or LPG stove or burner or anyone. Okay, so here you are supplying the heat energy, still the temperature does not change. That means what will happen to that heat energy which you are supplying? That means it is used to convert the one state of matter into another state, or from one phase to another phase, or from solid phase to liquid phase. That extra amount of heat energy which converts the states of matter from one phase to another is the latent heat. Understand? That amount of heat required to convert 1 gram or 1 kg, okay, into from one state to another state of matter is called the latent heat. Understood? See, when you are heating, slowly the temperature rises. At one place, slowly the temperature does not change, it remains constant, and only the phase change occurs. That extra amount of heat energy which you are supplying is a latent heat. Understood? Now we will see there are two types of latent heats, that is latent heat of fusion and latent heat of vaporization. First we will learn about latent heat of fusion. Okay, what is this latent heat of fusion? The amount of heat required to convert 1 gram of a solid ice. Let us take ice. Okay, for example, a solid or a solid ice completely into liquid at constant temperature. See here, ice melts. Already will I told you, ice while melting, the temperature remains constant. That temperature is called melting point. So at the melting point, okay, if you take 1 gram of a solid ice, how much heat energy is required? That heat energy is called the latent heat of fusion. That means it is latent heat of fusion is represented by letter capital L, and heat energy Q, and mass is M. Okay, so here you have to remember that, okay, the L is equal to Q by M. Latent heat is equal to Q, the quantity of heat energy, by M, mass. Okay, normally for ice, it takes 80 calories per gram. That is latent heat of fusion for 1 gram of a ice to convert into water. So latent heat of fusion of ice, not for all substances. Remember, for ice only it is equal to 80 calories per gram. Okay, this calorie, what are the units of the heat energy? Calories. Energy, it is calories. Okay, heat energy is also calories. Okay, this is about the latent heat of fusion, the extra amount of heat energy which is required to convert 1 gram of a solid ice completely into water or liquid is called, where temperature remains constant. So at a constant temperature is called latent heat of fusion. Now we'll learn about latent heat of vaporization. It is simply there is a change, phase change from liquid to gas. Okay, so remaining all same, formula is same. Okay, the amount of heat energy required to convert 1 gram of a liquid, okay, completely into a gas at a constant temperature is called latent heat of vaporization, not fusion. Okay, and L is equal to Q by M. Okay, and latent heat of vaporization of the boiling water, that means water, boiling water to become a water vapor, it is equal to 540 calories per 1 gram. 5, how much? It will be more. Okay, latent heat of vaporization. Understand? So there is a small difference. Fusion from solid to liquid, and vaporization from liquid to gas. Understand? Formula is same. L is equal to Q by M. And the heat energy which required to convert 1 gram of a liquid into gas is latent heat of vaporization. Understood, children? Good. Let us enjoy with a song. Okay. Thank you, children. Have a nice day. Thank you.